Cambridge Assessment Admission Testing, 6th-term examination paper. Step 2019 Paper 1, Mathematics 1, Code number 9465. Section A. The link to the question paper is in the description below. Hi, I am Babak. In this video, I'm going to solve and discuss the 5th problem of this sample paper, of this past paper. So let me read the first part of the question. The 4 points P, Q, R, and S are the vertices of a plane quadrilateral. What is the geometrical shape of PQRS if we know that vector PQ equals to vector SR? Okay. So let me just draw one equilateral for you here. Let us keep it as general as possible. So for example, I have this situation. Yeah, something like that. This is a very specific quadrilateral, so let me change my 4. And then this is better. Okay, so let me just clean this. Oops. Okay, so for example, let me start from here. So it doesn't matter where you start from. So for example, assume that I start from here, P, and then either I have to choose to go in that direction or I have to choose to go in this direction. So for example, if I choose to go in this direction, then if this is P, this becomes Q, and then this becomes R, and then this becomes S. So be careful. You're not allowed to write P, Q, R, S. This is not right. This is a convention, so you need to respect this order. So now what we know is that we know that vector PQ is equal to vector SR. So equality between two vectors gives me two pieces of information. One thing is that PQ as a line segment is parallel to SR, yes. So these two vectors are parallel, and we know that the norm or the length of this vector is also equal to the length of this vector. Now let us go back on the picture and interpret them. So here PQ is this one, is supposed to be parallel to SR. So these are opposite sides. They are not only parallel, but they also have equal lengths. So this quadrilateral has to be a parallelogram, yes? I have a quadrilateral. Two sides which are opposite to each other have the same lengths and they are parallel. This means that this quadrilateral is a parallelogram, yes? So the first part of the question is that PQRS is a parallelogram. Okay, so this is the first part. And now, what is the geometrical shape of PQRS if the vector PQ is equal to vector SR as before, but now we also have another extra piece of information. This tells us that the length of PQ is equal to the length of PS. So what is PQ? PQ is this one and P is this one. So it means that because PQ, the vector PQ is still equal to SR, so it means that PQRS is still a parallelogram. But now in this parallelogram, two adjacent sides, this one and that one, are also equal from length point of view. Okay, so I have a parallelogram. Two adjacent sides have the same lengths. So it means that this is a rhombus, yes? So in the second scenario, PQRS is a rhombus. Okay. So the first part was actually very simple. Now let me go to the next part. A cube with edges of unit lengths has opposite vertices at 0, 0, 0 and 1, 1, 1. The points P with coordinates P, 0, 0, Q with coordinates 1, Q, and 0, R with coordinates R, 1, and 1, and S with coordinates 0, S, and 1 lie on the edges of the cube. Okay, so of course in step exams you shouldn't rely on a very precise picture, but I have already done this picture with GeoGebra, so just let me just put it here in front of your eyes. But what is important is that you shouldn't rely so much on a good picture, of course. Yes, so let us consider this one. Okay, so you see the point P, a cube with edges of unit length. So this cube that you see here is a cube with unit lengths, and then the opposite vertices are 0, 0, 0, which is the origin here, and then 1, 1, 1. So this point is 1, 1, 1. I have called it A. Okay, and then these points lie on the edges of the cube. So for example, if you see this point P, Q, and then let me just, by the way, make the axis clear. So I'm considering this the x-axis, and this the y-axis, and this the z-axis. Yes. So the point P has coordinates P, 0, 0. Because of these coordinates, it means that the point P lies on the x-axis. So you see this is the x-axis, and P lies somewhere on the edge of this cube on the x-axis. And for example, Q has x coordinate 1, some given coordinate Q for the y, and then the z coordinate is 0. So when the z coordinate is 0, it means that the Q lies on the x or y plane. Yes, because the z coordinate is 0. And on the other hand, the x value is 1. So Q lies somewhere on this line. And similarly, you can just argue that R and S would be somewhere here and somewhere there. But as I told you, you shouldn't rely on a very precise picture. You can just draw this by hand. Okay, now let us see. Given that the 4 points lie in the same plane, show that this is satisfied. So for example here, this means that it might be on the same plane or not. Okay, these 4 points, there is no guarantee for 4 points to be on the same plane. If I have 3 points which are non-collinear, then it is guaranteed that they specify exactly one plane. There is only one plane, single plane, passing and containing all those 3 points. But if I have the 4th point, there is no guarantee for that. Okay? But now we want to show that if coincidentally these points be on the same plane, then this would imply that this relation is satisfied. Okay. My strategy to tackle this problem is I want to find an equation of the plane passing through these 3 points, and then when I found the equation of that plane, I will demand that this satisfies the equation of the same plane. And then hopefully from this consideration I will be able to get this constraint. Okay, but how should I find the equation of a plane which contains P, Q, and R? And of course you see that P, Q, and R, they don't lie on the same line. Yes, because by this construction P, Q, and R does not lie on the same line, so definitely they would specify exactly one unique plane. Okay, so how should I do that? So if you remember, so let me just give you some review. Assume that I have a plane, so this is a plane in a space, and then I am going to find an equation for this plane. What I know about the plane is that I know 3 points on the plane. Yes. Okay, one standard way of doing that is that you can find the vector PQ which lies on the plane, and then you can find the vector PR which also lies on the same plane, and then calculate the vector product of PQ and PR. This will give you a vector PQ times PR. It will give you a vector which is perpendicular to these two vectors, and consequently it becomes normal, it becomes perpendicular to my plane. Yes. So this vector here is, for example, PQ vector product by PR. Okay, and then as soon as I find the coordinates of the components of this vector, then assume that this becomes n1, n2, and n3. Assume that. Then I know that the equation of this plane would be of this form: n1 times x plus n2 times y plus n3 times z equals to some constant d. When I found n1, n2, and n3, I will demand that my plane will pass through one of these points, for example, say P. Using that, I will be able to find D, and it means that then I will have an equation for my plane. So I will follow this strategy. So, but following this strategy needs PQ as the vector. Okay, so let me write it a little bit smaller here. So PQ, what is PQ? So PQ is Q minus P, so I would write it is 1 Q and 0 minus P and 0 and 0. So if I calculate this, it becomes 1 minus P, then I will have Q, then I will have 0. So this is my PQ. And if I calculate the other one, which is PR, for example, and then it becomes R minus P, which gives me R minus P, 1 and 1. Okay, now what should I do? I need to vector product or cross product these two vectors, and hopefully you know that it goes like a determinant. So this becomes a hat, j hat, and k hat. These are the unit vector of the axes x, y, and z. And then I can put 1 minus p here, q here, and 0 here, or r minus p, 1 and 1 here. And then I start calculating this. Okay, the first component, I ignore this one and that one. I calculate this determinant 2 by 2 determinant, which becomes q times 1 minus 1 times 0, which becomes simply q. In the middle one, I have an extra minus sign. I need to take this one and this one away and calculate the determinant of what is left over, which becomes this times that minus this times this, which is 1 minus p. And then if I multiply this, it becomes minus 1 plus p. And finally, I will do the same thing here. So then it becomes 1 minus p. I need to calculate the determinant of this thing. So it becomes 1 minus p. So let me write it. 1 minus p minus q times r minus p. Yes. Okay, so what happens here if I simplify this a little bit? So this means that PQ cross PR is equal to Q P minus 1, and then I will have 1 minus P minus QR plus QP. So that would be the equation, sorry, that would be the perpendicular vector to my plane. Okay, so now I write the equation. So this is n1, this thing is n2, and this thing is N3. I plug them here, then I still need to find D. Okay, so let us just write that one first. So it becomes Qx plus P minus 1 y plus 1 minus P minus QR plus QP is times Z is equal to D. But this plane is supposed to pass through all of these points. Okay, so it means that the coordinates of the point P has to satisfy this relation. P is easier. Of course, you can use Q, you can use R, but you see that the form of P is much simpler here. P is 0, 0. So it means that if I replace X with P, if I replace Y with 0, if I replace Z by 0, then this should be satisfied. Okay, so what does it mean? It means that I have QP is equal to D. Okay, so what I got is that the equation, an equation for the plane passing through the points P, Q, and R is Qx plus P minus 1 y plus 1 minus P minus QR plus QP equals to, instead of D, I put QP. Yes? Okay, good. But now, what I'm going to do, so you see, let us read the question. Given that the 4 points P, Q, R, S lie in the same plane, show that this relation happens. So it means that because this point is also supposed to be somewhere in this plane, for example, assume that this is supposed to be S, it means that the coordinates of the S has to satisfy the equation of the plane. But let me remember. So what is this to remember? S is 0, S1. So let me write it here. 0, S1. Okay, so this should satisfy here. So okay, what happens? Instead of X, I put 0 plus P minus 1. So let me write this in this proper way. So I would say S belongs to the plane. So this implies that Q times 0 plus P minus 1 times S plus 1 minus P minus QR plus QP times 1 is equal to QP. Okay, so if you don't mind, let me take this one with me to the next page. Oh, let me see, can I fit it here? Yes, I think we can have it here. That's not a big deal. Okay, we can make it smaller a little bit, even smaller. Okay, here, so what happens? This vanishes totally, and then let us see at the relation we want to prove here. I have RQ on one side, so let me open it first. Yes, so this becomes PS. Let me keep it as this one, P minus 1S, but let me open that one, which becomes 1 minus P minus QR plus QP, because just multiplying by 1, and then I will have QP. Okay. So if you see here what I want to prove, I need RQ alone somewhere. Okay, so I do that. I move this RQ to the right hand side. So then it becomes P minus 1S plus 1 minus P plus QP. I move this QP. By the way, this QP and QP are cancelled. so I don't need to write it down. So PQ and PQ are gone. Okay, so PQ and PQ are gone, and then I keep 1 minus P here and move QR to the right hand side. Yes, but then look here, I can factor a negative sign out. It becomes 1 minus PS, and then I have 1 minus P, and on the right hand side I have QR. And then you can immediately see that I can factor 1 minus P out. So 1 is left from here, 1 is left from here, and minus S is left from there. So it becomes minus S equals to QR. And that is exactly the relation that we are supposed to show. Okay? Good. Now let us go to part 2, part A, the first part of part 2. Show that PQ equals to SR if and only if the centroid of the quadrilateral PQRS is at the center of the cube. Okay, note the centroid of the quadrilateral PQRS is the point with position vector 1/4 of the sum OP, OQ, OR, and OS, where O is origin. Yes. So if I can take my photo again here, okay, so yes, I can just put it here a little bit smaller. Okay, so let us keep it here. So what I'm supposed to do, you see, first of all, there is a definition here in this question. They are defining the centroid of the quadrilateral PQRS. So this is your quadrilateral if they are in the same plane, by the way. Otherwise, they are not forming a quadrilateral. If they are going to form a quadrilateral, it means that this equation should be satisfied. Yes? In that case, if you want to find the centroid of this quadrilateral, yes, in that case, if you want to find the centroid of this quadrilateral, you need to calculate OP, vector OP plus OQ plus OR plus OS and divide it by 4. Okay? This, according to the definition, gives you what we call the centroid of the quadrilateral PQRS. On the other hand, what is the center of cube? Center of cube is in the middle of this diagonal OA. Okay, so the coordinates of this point is 1, 1, 1. The coordinates of this point is 0, 0, 0. And then the center of this cube is, I will call it M. It is 1/2, 1/2, 1/2. Yes. So let me just write it down. M is 1/2, 1/2, and 1/2. The center of the cube. So remember that. Okay, now this is proving that, and let me call the centroid, for example, let me call the centroid C. Let C be the centroid of the quadrilateral PQ, what is that? PQRS. Okay, according to the definition, we have OC is equal to 1/4 OP plus OQ plus OR plus OS. Yes, so that is the definition of the centroid. Okay, now what we are going to show. Part A, so part 2, the first part, tells you that show that PQ is equal, the vector PQ is equal to vector SR if and only if the centroid of the quadrilateral PQRS, it means that C is at the center of the cube. So this is what we want to prove. Okay. Okay. So one thing that we can do here, first of all, you see that this is if and only if, so it means that I need to assume this is true to prove this is true, and then assume this is true and prove this is also true. Okay, but I would prefer to simplify this equivalently to reach to one other statement, and then simplify this and try to see that they are equivalent. Okay, so if you don't mind, let us follow this strategy. Okay, so I need the points here, so if you don't mind, let me write the points here in front of me. So P is P0, 0, Q is 1, Q 0, R is R1, 1, and finally S is 0, S 1. Okay. Okay, so let us consider PQ equals to SR. This is equivalent to saying that OQ minus OP, this is for the left hand side, is equal to OR minus OS. Okay, but what is OQ? This is your Q, so OQ becomes exactly the same, a vector with the same components 1Q and 0, and I will do the same thing for others. So it becomes 1Q and 0 minus P 0 and 0 is equal to, instead of OR we can write R1, 1, and then instead of OS I can put 0S and 1. Of course, let me emphasize here that this is a double-sided arrow again. Yes, so I want to simplify this expression in an equivalent way. Okay, so again I can conclude that I can subtract these two, I can subtract them, so it becomes 1 minus P, Q, and 0 is equal to R, 1 minus S, and 0. Again, this is a double-sided arrow. Yes, I can go back from here and decompose it and write it into that form. Okay, and then again, this is also equivalent to saying that 1 minus P is R and Q is 1 minus S. Yes, so I get these two relations. I get P plus R equals to 1 and Q plus S is equal to 1. So what I showed is that this statement is equivalent to this composite statement. So let me write it here for you. So PQ, we realize that PQ is equal to SR if and only if P plus R is 1 and Q plus S is also equal to 1. So this is what we got by simplifying this. Let me now start working here. Okay, so I would say that C is equal to M, again, if and only if OC is equal to OM. Yes, but what is OC? OC is here. Oh, I forgot to put the arrow here. So this is OC, and this is M, but OM would be the vector with the same components. Yes, so then this implies that 1/4 of OP plus OQ plus OR plus OS is equal to OM. Yes, yes, but OM is the same 1/2, 1/2, and 1/2. Okay, so I can multiply both sides by 4. So this 4 will be cancelled. This 1/4 will be cancelled. 4 will be multiplied here. So all these numbers become 2, 2, 2. And then let me add OP, OQ, and OR, and OS. So these are actually OP, OQ, OR, and OS. So let me add them. So then it implies that I'm adding all of them component wise. So it becomes P plus 1 plus R. The next one becomes Q. So let me explain it. P plus 1 plus R plus 0 is the first one. And then 0 plus Q plus R plus S, the second one, and similarly for the third one. So then it means that I will have Q plus 1 plus S, and finally I will have 2. This is equal to, if you remembered, I multiplied everything by 4, so on the right hand side I will have 2, 2, and 2. And then this is again equivalent to, so the last component is automatically equal to the last component. So it means that this has to be equal to this, and this has to be equal to that. So then this implies that P plus 1 plus R is equal to 2, and Q plus 1 plus S is equal to 2. But then I hope that you agree that this is also equivalent to P plus R is equal to 1, and Q plus S is also equal to 1. Yes, I just moved this 1 to the right hand side, 1 to the right hand side. So what I got is this. This expression, C equals to M, this statement is equivalent to this statement. So let me write C equals to M if and only if this happens, that P plus R is 1 and Q plus S is also equal to 1. And I hope that you can immediately conclude from 1 and 2 that what you want is actually true. Yes, why? Because this statement is equivalent with this statement, but that statement is exactly what is written here, which is also equivalent to this statement. Okay, so by comparing 1 and 2, you can immediately conclude that PQ equals to SR is equivalent to saying that C is equal to M, and then we are done. Okay, good. Now let us go back. I don't know how much space I am left, so it's better to go to the next page. Yes. Here, let us read this one again. So, given that PQ is equal to SR, remember, PQ equals to SR is exactly the same thing as before. And on top of that, we have PQ equal to PS. Yes? We are supposed to express Q, R, and S in terms of P. Okay, but let me go back and borrow this. Yes, you remember I proved this thing that PQ equals to QS is actually equivalent to this expression. So let me copy this one with me and take it, oops, to the other page. So I realized that this is the equivalent. So it means that in this part of the question, if necessary, I can use these relations. On top of that, I know that PQ and PS have the same lengths. So if you don't mind, let me go back again, see that what are PQ and PS. So what is PQ? If you see here, PQ, I simplified PQ here. I got this and I got this. So this is PQ and this is SR. Yes. But PQ, sorry, here I need PQ and PS. Okay, so let me take the, so we have the points here. So we have, yes, so we can go back here. Okay, so what is PQ? Let me write them again. So what is PQ? PQ is OQ minus OP. So OQ minus OP is 1 minus P and Q and 0. And what is PS now? PS is equal to minus P, S, and 1. So let me double check. PQ, P and Q. So 1 minus P, Q minus 0, 0 minus 0. Okay. And then I have PS. So what is PS? PS is S minus P. So 0 minus P is minus P. S minus 0 is S, and 1 minus 0 is 1. That's okay. But now what I know an extra condition here, that the lengths of these two vectors are supposed to be the same. So it means that the norm of PQ, so the length of PQ is equal to length of PS. So then it means that the square root of 1 minus P to the 2 plus Q to the 2 plus 0 to the 2 is equal to square root of minus P to the 2, which becomes P to the 2, S to the 2, and 1 to the 2, which is 1. And then it implies that what I have under the square root signs are the same. So I expand the first one by quadratic rule, and then I have Q squared is equal to P squared plus S squared plus 1. And then you see that this P squared and this P squared and this one and that one are cancelled. So what is left for me is minus 2P plus Q squared is S squared. Yes, so this is also one relation. Now let us read what we want, what is wanted. We are supposed to express Q, R, and S in terms of P. Okay, so now I have 3 equations actually. This is question number 1, sorry, equation number 1, equation number 2, and equation number 3. How many unknowns do I have? I have 4. P, Q, R, S. But I'm not supposed to find all of them. I am supposed to find 3 of them in terms of the other one, which is P. So it's possible. So from number 1, I can immediately write R in terms of P, yes? So P plus R, so number 1, P plus R is equal to 1. So what I get is that R is equal to 1 minus P. Simple as that. But then I need to find Q and S in terms of. So from number 2, for example, what can I do? I can we can use the trick. I realize that. So here I can start with number 3. This gives me minus 2P is equal to S squared minus Q squared. You agree? So here I moved Q squared to this side. But then I can see that I have a conjugate pattern, so it becomes minus 2P. It's S minus Q and S plus Q. But what is S plus Q? S plus Q is 1. So here I can put 1. What I get is that Q minus S is 2P. Okay? And then I can call this one number 4. Then I can consider number 2 and number 4. And then I can find Q and S immediately in terms of P. Yes? So let us do that together here. So 2 and 4 gives me this system. Q plus S is equal to 1. Q minus S is equal to P, to 2P. So I add them, then Q, 2Q becomes 1 plus 2P. So I divide it, becomes P plus 1/2. Yes? So that is also Q. And I can plug it here. S is 1 minus Q. So then S becomes 1 minus P. So it becomes 1/2 minus P. Yes. Good. Okay, so that was this part of the problem. And then we are supposed to show that this relation holds. We want to find the cosine of the angle PQR. Okay, So, for example, let us just sketch something for understanding. So assume that this is Q, this is P, and this is R. So assume that my goal is to find this angle. Yes, that's the angle PQR. Okay, so you be careful. For example, if you take this vector and that vector, the angle between these two vectors is actually this angle. So be careful. If you calculate the angle between this vector and that vector, what you are calculating is this blue angle, which is the complement, which is the supplement of this angle. Yes. So if you want to calculate this, and if you are taking the vectors like that, you need to remember that you need to subtract this angle that you get from 180. But let us not give ourselves a headache. So what I do, I clean everything here. I will take QR and QP. Then in that case, the angle between these two vectors is exactly what I want to calculate here. Okay, but do you remember this was PQ? So QP is the negative of this vector. So what is QP? QP is P minus 1 minus Q and 0. Okay, and then I need also QR. Okay, so what is QR? QR is R minus Q. So look here. This is R, this is Q. R minus Q becomes R minus 1, 1 minus Q, and finally 1. Yes, let me double check. R minus Q, yes, R minus 1, 1 minus Q, 1, yes. Now you know the formula. If I want to find the cosine of that angle, cosine of PQR, yes, this is equal to the vector QP dot vector QR divided by the norm of the divided by the magnitude or length of the first vector multiplied by the length of the second vector. Let me continue. So what is QP? QP is P minus 1 minus Q and 0 dot what is QR is R minus 1, 1 minus Q and 1, and in the denominator I will have the length of QP, which is square root of P minus 1 to the 2 plus Q to the 2 plus 0 to the 2, and I don't need to write it down, multiplied by, so let me take this multiplication away, and then I have square root of the length of QR, which is R minus 1 to the 2, plus 1 minus Q to the 2, and then finally plus 1. Okay, and then what happens, let me multiply this, let me do this inner product. So I need to multiply this by that, and I need to multiply this by this, multiply this by that, and then add the results. Yes, so then it becomes P minus 1 times R minus 1, and then I have minus Q times 1 minus Q. The next one is of course 0. And if you don't mind, let me calculate these powers. So it becomes P squared, and I will write minus 2P plus 1 plus Q squared for the first one, and the second one becomes R minus 1 to the 2. So I would say that probably this is not a very good way. So let me keep them in that way for the time being. Let us simplify algebra a little bit. Because if you look at the expression you are supposed to find, everything is expressed in terms of P. So it means that finally I have to be able to get rid of R and Q in favor of P. Yes? But I can immediately do that because I know what is Q. So Q is P plus 1/2. Okay? Okay, so So let me just write it down for the time being. P minus 1 to the 2 plus Q to the 2 multiplied by R minus 1 to the 2 plus 1 minus Q to the 2 plus 1. Okay. But let us start doing something. I want to write everything in terms of P. Okay, so let us divide this. So numerator. Let us see what is numerator. So P minus 1 is okay. But instead of R minus 1, so what is my R? Do you remember? R is 1 minus P. So instead of R, I put 1 minus P. It becomes 1 minus P, and then I have minus 1. Minus, what can I put instead of Q? Q is P plus 1 half. So it becomes P plus 1 half. And then I will have 1 minus P plus 1 half. But this is easy to calculate, yes? Because this minus 1 and that one are cancelled. I am left with minus P. I multiply it inside. It becomes positive minus P squared positive P. But look here, what is this one? This is 1 minus P minus a half. So it becomes 1 half minus P. And this is 1 half plus P. So this gives me a conjugate pattern. So then it becomes 1 over 4 minus P squared. But I have a negative sign. It becomes, this one becomes negative. This one becomes positive. And the good point is that, okay, this one and that one are now gone. So the numerator, so let me write numerator, is equal to P minus 1 over 4. Yes? Okay, so I need to calculate the denominator now. Okay, so let us calculate the denominator as well. So in the denominator, for the denominator, I can calculate this one. So what is this one? This is P minus 1 to the 2 plus Q2. Then what I get is P minus 1 to the 2. Instead of Q, I put P plus 1 half. So this becomes P plus 1 half to the 2. So let us calculate this. I will get a P squared from here and here, so it gives me 2P squared. I will get a P from here and minus 2P from here, so it gives me minus P. And I will get a 1 from here and 1/4 from here, so it gives me 5 over 4. Yes. Yes. And then, okay, so I need to calculate the other one here. I want to calculate this one here. Hopefully I can fit it here in this one, in this space. Sorry a little bit for the mess, but I think let us calculate it here. Okay, so this becomes R minus 1 to the 2 plus 1 minus Q to the 2 plus 1. Let us calculate this part. So what is R? Look, R is 1 minus P and Q is P plus 2. Yes, so I can just replace them again. So what happens? Instead of R, I put 1 minus P, so it becomes 1 minus P minus 1 to the 2, and then plus 1 minus Q, which is P plus 1 half to the 2, and then I have plus 1. But then this one becomes P squared, yes, because this negative 1 and then 1 are gone, so it becomes P squared. And then what happens for the next one? It becomes plus 1 minus a half becomes 1 half, and then minus P to the 2, and then finally I have 1 at the end. The last thing that I need to simplify, I have a P squared from here, a P squared will come from here, so it becomes 2P squared again. And then I have only 2 times the first one times the second one, which gives me minus 2P. And then I will get a 1 over 4 here and 1 here, which gives me 5 over 4. So it's very interesting actually. So if you see the result here for this for the under square root sign here and under square root sign here, both of them are exactly the same expression. Sorry, I made a mistake here. 2 times the first one times this 2 times the first one times the second one is not minus 2 pi, is minus pi. Okay, it's minus pi. Okay, so you see that this expression here exactly is expression here. So what does it mean? It means that these two square root signs, both of them are square roots of the same expression. So if I multiply them, the square root sign will be cancelled and I will be left with this expression in the denominator, and I have already calculated the numerator. So what I get is that cosine of this angle PQR is equal to, the numerator is P minus 1 over 4 and the denominator is 2P squared minus P plus pi over 4. Yes, but what I am supposed to show, let us check. Okay, you see here I don't have any fraction, so I will multiply everything by 4. Yes, so if I multiply everything by 4, the numerator just becomes 4 pi minus 1. Then this becomes 8 pi squared minus 4 pi plus 5. Yes, so if you want, I can take this one. So we should be able to yeah, I hope that you are convinced that this is actually indeed true. Yes, so 4 pi minus 1 in the numerator, 4 pi minus 1 in the numerator, and then I have 5 minus 4 pi plus 8p squared. 5 minus 4 pi plus 8p squared. So that's exactly the one that we are supposed to find. Okay, sorry for that mess there. It was harder if I want to actually copy paste everything. Okay, so let us come to the final part of the problem. So write down the values of P, Q, and R and S if P, Q, R, and S is a square, and show that the length of each side of this square is greater than 21 over 20. So we are supposed to determine the values of P, Q, R, and S if on top of everything P, Q, R, and S is a square. So if I want to just simply convince myself, so assume that I have this one is a square. P, Q, R, S is also in a square, So this is equal to that, equal to this, and equal to that. Okay, so what does it mean? When you say that P, Q, R, S is a square, it means that this is already satisfied. You see, P, Q, and S are the same vectors. And then the length of PQ is also equal to length of PS. Let us see, the length of PQ and the length of PS are actually equal. So these two conditions are enough to conclude that this is the relationship between P, Q, and R. Okay, but then so it means that this is already satisfied. But what is PQR? The angle PQR in this case is 90. And we know that the cosine of 90 is 0. So it's very simple now. So cosine, so PQR in this case, the angle PQR is 90 degrees. So this means that the cosine of PQR is equal to 0. And then using this relation, this is important. Why this relation is still satisfied? Because when you have a square, these two conditions are automatically satisfied. So it means that I can use this relation which just relies on these two expressions. So what does it mean? It means that I have 4p minus 1 divided by 5 minus 4p plus 8p squared is equal to 0. So this means that 4p minus 1 is equal to 0, and I will get p is equal to 1 over 4. Okay, but when p is equal to 1 over 4, I can immediately calculate, you see, from here I can calculate r, which is 1 minus 1 over 4. So let me write it here for you. So r is 1 minus p, so it's 1 minus 1 over 4, so it becomes 3 over 4. So then r becomes 3 over 4. And then we need to go to the other page again. So here we also have q is equal to p plus a half. So q is p plus a half. So q is p, which is 1 over 4 plus a half. So it becomes 3 over 4. So q is just 3 over 4. And finally, if you go back, sorry for just going back and forth a lot of times. So here s is 1/2 minus p. So then s is also calculated. So s is 1/2 minus p, so it becomes 1/2 minus 1 over 4, so s becomes 1 over 4. Okay, now the very last bit of the problem is that now we are supposed to show that the length of each side of this square is greater than 21 over 20. Okay, it's very simple now. It doesn't matter which lengths you want to calculate here. So for example, let us say calculate PQ again. Okay, so what is PQ? PQ is, the vector PQ is Q minus P, which is 1 minus P and Q and 0. Yes, but now I know the value for Q and I also know the value for P, so I put them here. Becomes 1 minus 1 over 4, 3 over 4, and 0. So it becomes 3 over 4, 3 over 4, and 0. Now I am interested in the length of this vector, which is the length of the side of my square. It becomes the square root of the first one to the 2 is 9 over 16, and the other one is 9 over 16. Then it becomes the square root of 9 over 8, which becomes 3 over 2 square root of 2. So that is the length. And then I am supposed to show that 3 over 2 square root of 2 is greater than 21 over 20. This is the question mark. But because we are not allowed to use the calculator in this exam, so if we want to do it mentally, we need to simplify this in an equivalent way so that we come to some simple statement that we can immediately see that this is true. Okay, so what I do, I would write 3 over 2 square root of 2 is greater than 21 over 20. This happens if and only if I multiply both sides by 3 over 2, by 2 over 3. Yes, this is again equivalent to this 3 and 3 cancel, this 2 and 2 are cancelled, so I am left with 1 over square root of 2, and on the right hand side this 3 and this becomes 7, and this 2 and this becomes 10, so it becomes 7 over 10. Yes, greater than 7 over 10. Yes, and this is also equivalent to, if I multiply both sides by 10 square root of 2, the left hand side becomes 10, the right hand side becomes 7 square root of 2. And this is also, because these numbers are positive, this is also equivalent to saying that, 10 to the power of 2 is greater than 49 times 2, and this means that 100 is greater than 98. And this is always true. And because these are all equivalent all the way up to this point, it means that we actually succeeded to prove this. Okay, I hope that you have enjoyed the video. If that is the case, Probably, please don't forget to give me a like actually for the video, and then if you want to be informed immediately about other videos that I will upload, please subscribe to my channel. And of course, I actually appreciate if you have any questions. For example, you might be interested in another problem from some other exam. So if you can communicate with me on the comments on the videos and just give me the link to the problem that you are interested. Might be I will be able to make a video for that particular question first. Yes. Otherwise, I will continue to solve the problems of this past paper. After finishing paper 1, I will go to paper 2 and finally to paper 3. Okay? Okay. Thank you for watching. And goodbye.